Hello to everyone. Let's talk about Way ANOVA. So we perform Way ANOVA when we want to compare a mean of different groups. Consider that we have two factors. So let's have here a data set. We can attach I's data set. So let's say we will start from this library and we attach here R's data set. So we can as we have two factors, we will have to add one more factor. So because we need two factors to run Way ANOVA, so we can add level, and the level will be low or high or high. So now we can see the first two rows from Iris. Yeah, so we see the first two rows will run, and here we have the first two rows. So we have two factors. The first one is species and the second is level. So let's see clean. So the first step, we will have to see in the histogram how the data is distributed. So let's see for species. No, let's see for the variable that we are using to compare the mean. So we have from Iris, we need a sample with. So when we run, we see, and when we look, we see that it's suggesting that it's normally distributed as we have this curve here. So, but we also can run a Shapiro test, so to make sure. So here we have Iris. Okay, and when we run Shapiro test, so we get p-value 0.1. It means that it is greater than 0.05. So it means that the Shapiro test is suggesting that the data is normally distributed. So we can add first assumption. We pass it. Now let's go to the second assumption, because when we run ANOVA, it's supposed that the data, the variance of different groups have to be equal or have similarity between them. So let's now run. Second would be living testing, but first we will have to get this data in linear model. So we have here our variable, and we have a factor, and also we have the interaction between these two factors, and we have our data. So now let's run to see if all is okay. Something wrong here. So okay. Now I think that's okay. Now it's okay. Now we can run our living test, and okay. So we run, and we have p-value 0.8 is greater than 0.05. So it means that there are equality or similarity between variance in the variance between different groups. So now we are okay to run ANOVA. It's all assumption. We will pass it. So let's now run ANOVA. So when we run ANOVA, so here I will have the last column where we have p-value. And when we look to the last column, we see that the p-value for species is very low, lower than 0.05. It means that these have a great effect in the means of different groups. But when you look at the level, it's greater than 0.05. It means that not have effect in the means of different group, and also its interaction does not have effect in the means of different group. So we will also consider species to further analysis. So now that we saw that at least consider species factor, at least one group is different from other, we can conduct a follow-up test. So, and we will not conduct follow-up test with the interaction between these two factors, but we all conduct follow-up tests with species because it's the one that have a great effect in the difference between the means of different groups. So follow-up test. So we have data, R's, and then now we run the follow-up test that we run for this case is Tucker HST, and we'll run. So here we have we see significant vertical and setosa and Frigidica and acetosa this means of these groups are different, but the model does not suggest the difference between Versicola, Virginica and Versicola. So thank you for watching. Please don't forget to subscribe and like.